myself Raju. Today we are going to discuss on IoT in data analytics. Okay, so today's session agenda is to talk about edge and fog computing. Let's talk about accelerating digital transformation through connecting and cognition. What is digitalization? Digitization is a massive scale through the edge technologies like actuators, beacons, chips, codes, controllers, LEDs, sensors, specs, stickers, tags, etc. That is, every common thing in our midst becomes digitized entities, smart objects, sentiments, materials that are capable of contributing for mainstream computing. Connectivity. Embedded systems are networked to communicate, collaborate, correlate, and corroborate with one another. This is nothing but the connectivity between the IoT systems, like day-to-day, device-to-device, and device-to-cloud integration, thrive towards sophisticated applications with the maturity of the IoT. IoT is nothing but Internet of Things technologies and cyber-physical systems. Next is cyber service enablement. Service enabling the digitalized and connected entities leads to the realization of scores of digital and device services. Data virtualization. When billions of different and distributed services interact, massive and multi-structured data gets produced and has to be collected and cleansed. Context information has to be embedded with digital data. Digital integration by cognition. Applying big, fast, and streaming analytics on digital data systematically is to create predictive, prognostic, prescriptive, and personalized insights, which can be looped back to the people and systems to take timely decisions and to plunge into actions with all the clarity, confidence, and correctness. This is the overall overview of the IoT in data analytics. How can we achieve IoT in data analytics? IoT in data analytics can be achieved by digitization and digital intelligence. It paves the way for digital empowering and transformed enterprises. Internet of Things. What is Internet of Things? Internet of Things is nothing but sensing, analyzing, and visualization using a set of tools or set of sensors. Home. In home, we can see health, entertainment, security, utilities, and applications. And in transport, we can see logistics, traffic, parking, emergency services, and highways. These are all the Internet of Things examples where we can see them and we can use them. In community, we can see smart metering, factory, business intelligence, surveillance. In doctor, healthcare, home personal users, policy makers, and industrials. How to make IoT environment intelligent? An IoT environment comprises scores of networking, things, resource, constraint, and intensive, and embedded systems, digital objects, connected devices, and virtualized. IoT artifacts are not individual intelligent. The character is to make them intelligent individually as well as collectively. The Internet of Agents. For empowering each digital object to be adaptive, articulate, reactive, and cognitive through mapping on software agent for each of the participating digital objects. The concept of digital twin and virtual object is also maturing and stabilizing. The proven and potential IoT data analytics at each edge and cloud levels is to prominent and dominant aspect for knowledge discovery and dissemination. The application of artificial intelligence. The application of artificial intelligence technologies like deep learning algorithms, computer vision, natural language processing, video processing, etc., leads to the realization of the smarter system, services, and solutions. The new concept of smart control contracts. The new concept of smart contracts is nothing but being popularized through the blockbuster blockchain technology, leads to sophisticated and decentralized applications. This is how we can make IoT environment intelligent. Data analytics towards sophisticated IoT environments. There are environments where you can see more of the sensors in the IoT. So why IoT data analytics? It establishes a variety of smarter environments. We can say such as smarter homes, hotels, hospitals, etc. It uncovers timely and actionable insights for machines and men, enables the realization of smart objects, devices, networks, and environments, leads to the production of pioneer and people-centric application and services. It helps people um, produce a very people-centric application, helps to come out with precise predictions and prescriptions, facilitates process excellence and people productivity, guarantees preventive maintenance of infrastructures, ensures the optimized utilization of distributed assets through monitoring, measurement, management for perfect inventory replenishment. I think it safeguards the safety and security of people and property, monitors complex environment to guarantee business performance, productivity, and resilience. Data analytics at public clouds for smarter homes. How we can create a smarter homes. A smarter home, it requires for sensors like for light, gas, temperature, smoke, and humidity. We can use a microcontroller such as Raspberry Pi. We can use the database cloud for such as Amazon Web Services for database, and can use some of the REST APIs for sensor to store the sensor data. Amazon EC2 instance, and you can read those sensor data into SDK for Android. You can check those in the mobile application itself. If there is any alert, then you can just send it to the emergency contacts or alert if the fire occurs in a house. This is how we can make a smart application using for smart homes. Why data analytics on clouds? Why do we use clouds in data analytics? Agility and affordability. No capital investment of large size infrastructure for analytical workloads. Just use and pay, quickly provisioned and decomposed once the need goes down. Data analytics platform in clouds. Therefore, leveraging cloud-enabled and ready platforms, generic or specific, open or commercial grades. Yes. Hmm? Data analytics platforms in clouds. Therefore, leveraging cloud-enabled and ready platforms like generic or specific, open or commercial grade, etc. Are fast and easy. No SQL and new SQL database and data warehouse in clouds. All kinds of database management systems and data warehouse in cloud speeds up the process of next generation data analytics, database as a service, data warehouse as a service, business process as a service. You can use wide area network optimization technologies. There are WAN optimization products for quickly transmitting large quantities of data over the internet infrastructure. Social and professional network sites are running in public cloud environments, enterprise class applications in clouds, all kinds of custom facing applications. Next thing is called as anytime, anywhere, and any network, any device information and service access is being activated through cloud-based deployment delivery. Sensor, device to cloud integration frameworks, and cloud integrators, brokers, and orchestrators. The distinct capabilities of IoT data analytics platforms. What are the capabilities of data analytics platforms? The capabilities of data analytics platforms could be scalability, faster data integration, better read and write performance, faster query processing, flexibility, and portability. Distributed processing through automated sharding, better data compression, integrated and end-to-end platform for all kinds of data analytics, machine and deep learning capabilities, RESTful interfaces, in memory and in database application analytics. Fog computing architecture. In fog computing, we can see cloud, fog nodes, IoT devices, and sensors. The device categories. The device can be categorized as category 1 can be low end, next thing will be high end, but next one will be sync nodes such as Raspberry Pis. Category 4 can be low end computational devices such as our smartphones. Next thing is high end computational devices such as PC and cloud. Why off-premise cloud is not suitable for certain IoT data analytics. Cloud is centralized, federated, consolidated, shard, automated, compartmentalization, and programmable infrastructure. Latency and response time is often a critical part. Using is the bandwidth and cost and capable capacity is very often underestimated. Security and privacy. Transmitting device data over an open and public network is risky. Power consumption. Cloud computing is energy hungry, and this is a concern for low carbon economy. Data obesity. Then offline usages versus online usages. Pure cloud services do not allow offline usages. It is a major shortcoming since major cities and industry 4.0 applications require a dual offline plus online paradigm. Why IoT data analytics has to be a real-time and at edge, volume and velocity, security, bandwidth, real-time data capture, storage, processing analytics, knowledge discovery, decision making and actuation, less latency and faster response, context awareness capabilities, combining real-time data with historic state. The device clouds for edge analytics. Xcloud is a club together multiple and heterogeneous devices such as the set-top box, gateways, multi microcontrollers, and other reasonable powerful devices in vicinity to form an ad hoc device cloud to produce and process all kinds of sensor and IoT data. There are primarily two platforms: Everywhere Cloud. There are several custom implementations. Edge analytics platforms has certain features such as injection of device event or video streams, manage device configuration and properties, automatically aggregate and query time series of a sensor data, maintain durable message queues per device, enrich real-time of streaming data, accelerate various real-time analytics queries, notify real-time event processing service in case of detected changes. The industry use case of Fox plus edge computing, where we can see IoT edge analytics in use cases. Manufacturing, oil manufacturing. In manufacturing, from creating semiconductors to the assembly of giant industry machines, yields and efficiency using real-time monitoring and diagnostics, machine learning, and operations optimization. Oil and gas extraction. There are high-stakes technology-driven operations that depend on real-time on-site, are very remote and lack reliable, high-speed access to centralized data centers, maximum production and safety. Next thing is mining. Mining faces extreme environmental conditions in very remote locations with little or no access to the internet. As a result, mining operations are rely more and more on edge intelligence for real time. On-site monitoring and diagnostics, alarm management, predictive maintenance to maximum safety. IoT data analytics use cases. The next one is called as transportation. In transportation, where we use IoT data analytics. In transportation, we use as part of the rise in the industrial internet, train and tracks, buses, aircraft, and ships are being equipped with a new generation of instruments and sensors generating petabytes of data that will require additional intelligence for analysis and real-time response. Next thing will be the power and water. In power and water, the unexpected failure of electrical power plant can create substantial disruption to the downstream power grid. So we can use IoT data edge run. The same holds true when water disruption equipment and pumps fail without warning. To avoid this, edge intelligence enables the proactive benefits of predictive maintenance and real-time responsiveness. Next thing is the renewable energy. In renewable energy, new solar, wind, and hydro are very promising sources of clean energy. However, constantly changing weather conditions present major challenges for both predicting and delivering a reliable supply of electricity to the power grid. Next thing is the healthcare. In the healthcare industry, new diagnostic equipments, patients monitoring tools, and operating technologies are delivering unpresentable levels of patient care, but also huge amount highly sensible patient data. But processing and analyzing more data at the source, medical facilities can optimize supply chain operations and enhance patient service and privacy at a much lower cost. Retail. To compete with online shopping, retailers must lower cost while creating enhanced customer experience of service that online stores cannot provide. Edge intelligence can enrich the user experience by delivering real-time channeling personalization and supply chain optimization. Smart buildings. Among the many benefits of smart building technology are lower energy consumption, better security, increased occupant comfort and safety, and better utilization of building assets and services. Rather than sending massive amounts of building data to the cloud for analysis, the smart buildings can use edge intelligence for more responsive automation while reducing bandwidth cost and latency. IoT data edge analytics use cases. You can see them in smart cities, drones, flying robots, unmanned aerial vehicles, connected devices. Connected vehicle devices adds an entirely new dimension to transportation. Thank you.